Hi, this is Nikhil. I am working with Tektronix as an application engineer. Today in short video we are going to talk about complementary cumulative distribution function and its importance in wireless communication or digital communication. The communication as it trends from analog to digital, the power level are also going to be varied from absolute power level to the average power level. Now wireless modulation or digital modulations are going to have a peak to average power ratio also very much higher. For the design engineers, that's where the challenge comes in. Now, wherever the power level which is below the average, they are going to clip or they are not going to store into the system. So designer has to design those subsystem devices like mixer, amplifier, filters, such a way that they are always to the type specification or they always maintain the power level above the average. Not only that, but the peak to average power ratio also has to be maintained in a same fashion. So that's where the CCDF will really going to help. The digital modulations are the signals which is time and phase which is going to be continuously varying. Now this signal changes both in the time domain and frequency domains appears like a noise. So for the noise kind of signals to characterize, the statistics is more important, and that's where CCDF also helps a lot. Ccdf curve also relates what information is the what amount of power level with respect to the probability of percentage. That's where the CCDF is going to play a key role in telling the users that how much probability of that particular power being in that signal. In another word, for the amplifiers, if there is also a way to characterize the P1 dB through CCDF curve also. Now let's see how to do these measurements with the spectrum analyzers. Here is the signal view software. We have loaded with the LT 20 MHz signal. Now we talk about that modulated signals looks like a noise, whether in the frequency domain representation or time domain representation. So let's have a quick look at that first. So I'm just turning on the time overview, which will help us to analyze the signal into the time envelope mode. So here we can see this signal is quite a RF envelope. So the burst communication which is happening, and then another burst of signal which is running in. Let me play the same waveform, and as you can see around the signal more or like, if I expand it here, looks like quite a bit noise. So it's really difficult to analyze and interpret the signal. Very much similar onto the frequency domain also. If I just reduce down the bandwidth right to the 5 MHz, so within that we are seeing that the signal is more or like looks like very much noisy. So the statistical measurements will help in this. Just to do the CCDF measurements, we start with the display. You have to come into the RF measurements and turn on the CCDF, and okay, right now I'm not need of this time domain representation, so I'm getting rid of it. And as you can see here, this is the CCDF curve. Now CCDF curve is as we talk about, it shows basically the representation of the power level probability. Now CCDF curve is majorly is defined by how much time of the waveform spends at or above a given power level. The percentage of time the signal spends at or above level defines the probability for the particular power level. For capturing a lower probability down to as low as like 0.001 percentage, the measurement made in a single all the equation, however the digitizers digitize the signals and pass it on to the signal view software. Now these are quite time dependent as we see. However, the higher the time we give, or higher the time we acquire and give it to the CCDF, the rarest signal we will be able to see through it. So that's where CCDF display will help in that. As you can see here, the waterfall curve and the point mark is shown as a particular power level, and the display which is right here shows the average and peak power. Right now the average power is considered as like minus 12 dpm with 35 percentage of time, and this also shows the peak to average power level, which is let's say right at the 10 dpm. So if you just move down to the 10 dB, we will see the what is the probability of around that particular power level. So I'm just moving out to 10 dB, and we can see is the probability which is in terms of 0.01 percentage of it. So this is the scale which is on the signal view, right from 0.0001 to 100%. The CCDF curve, this way it will really help to visualize the effects of different modulation formats, as well as when the multiple systems are getting combined to evaluate how the really spread spectrum works. And this way it will help to design and validate different RF systems, subsystems to RF component level for different power level measurements. Uh, so that's what for the CCDF in this video. I hope you enjoy the video. Please like and subscribe to our channel Tech Hint. Thank you for watching.